Hello dear students, once again welcome back to our channel. In this video we are continuing exercise 6.5 question number 11. Two aeroplanes leaves an airport and flies due north at the speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far apart these two planes after 1.5 hours? That is the question. Okay, that means in short, in 1.5 distance, after 1.5 distance, okay, we should get where will be the planes if they are moving in their respective speeds. Okay, suppose this is the airport, okay, and from this point a flight moves due north, okay, so and its speed is 1000 km per hour, that is given, speed equal to 1000 km per hour, plane which moves due north. And from the same time, from the same airport, another flight is flying towards west, and its speed is given as 1200 km per hour. Okay, and after 1.5 hours, okay, we have to find out the distance between these two aeroplanes. That is the question. So suppose this is the distance travelled by the second plane in 1.5 hours, and this is the distance that first flight is here after 1.5 hours. Okay, so let it be A, B and C. Okay, so here definitely here it will be in 90 degree. So you can apply Pythagoras theorem. So here the problem is, what is the distance travelled by this first flight in 1.5? If the speed is given as 1000 km, okay, and we know that the speed is equal to d by t, and since we need a distance, so s into t, speed into time, that is speed is equal to, for the first aeroplane, 1000 km, and after 1.5, time equal to 1.5 hours, that means this should convert into improper fraction, that is 3 by 2. Okay, this much hours in fraction, in mixed fraction into improper fraction, so that we can substitute here. Okay, that is 3 by 2. This is the distance travelled by the first aeroplane in 1.5 hours, within 1.5 hours. So this 2 in 1000, 500, 5 3s are 15, 1500 km. This is the distance travelled. If 1 hour is 1000, 1.5 is half of 1000 is 500, so 1000 plus 500 is 1500. That way also you can calculate, doesn't matter, but I just applied the formula. The same way the second flight, okay, the distance travelled, that is BC, and this is this distance can be represented with the AB. Okay, the second aeroplane, that is BC, the distance travelled by the second aeroplane within 1.5 hours, being the speed is 1200 is given. So speed into time, this distance, 1200 into 3 by 2, both at the same time after 1.5 hours. So 1.5 in mixed fraction, 3 by 2, improper fraction 3 by 2. So here 600, 6 3s are 18, 1800 km is the distance travelled by the second flight. Okay, after 1.5 hours, the flight will be here at this point. And the distance between these two flights after 1.5 will give you this AC. So we can apply Pythagoras theorem upon this triangle, right triangle ABC. Okay, by Pythagoras theorem. By Pythagoras theorem, okay, AC square, square of the hypotenuse, AC square equal to AB square plus BC square. Okay, we can substitute for AB. AB is here 1500 square plus BC 1800 square. Okay, this is AC square. And 15 into 15, that is 225. And 00, and when you square you will get 2 more zeros. Okay, this is a square of 1500. Okay, and in the second term 18 into 18, 324 and 4 zeros. This is a square of 1800. Okay, a non-zero number 18 into 18, that is 324. Okay, and 20, and in square it will have 4 zeros. That is for the two numbers. Okay, so we can add, that is 3, being it is 4040, and altogether it has 7 digits. So you can in the answer 4 zeros and 324 and 225. Okay, 5 and 4 9, 2 plus 2 4, right? So 2 plus 3 5, that is, this is AC square. What we need, the distance is AC. Okay, between these two flights after 1.5 hours. So AC square is this one. So AC will be square root of 547 and 40. See children, we know that a square number 4, this 4 zeros. Okay, this can be written in the form. We know that 547 is not a square number. Okay, after 529, the next square number is 576. No other square number between these two. Okay, so you can write this in this form because it has 4 zeros in terms of 10,000. Okay, a square number always end with even number of zeros. Okay, so this will make 547 into 1, 2, 3, 4 0. That means this is 100 into 100. So 100 can be taken outside. Okay, that means here still 100 into square root of 547. Understood? It is clear? Okay. See here 100 into 100, and under from the inside the square root I have taken 100, and still this 547 is there. Okay, now we are going to what is it? 549, right? 549. Okay, so here we are going to prime factorize in order to get the square root of 549. Okay, so we can here prime factorize 549. See children, 5 plus 4, 9 plus 9, 18, multiple of 3. So you can divide this number with 3. So 3 in 5 one time, and 24 8. 8 3s are 24, and in 9 3 times. Again you can start with the 3 because sum of the digits is multiple of 3. 9 plus 3 12. So 3 in 18 6, and 3 in 3 one time. 61 is a prime number. 61 is a prime number. So this 549 is square root of 549 is 3 into 3 into 61. That is, from this pair 3 you can take 1 3 outside, but still root 61, that 61 is in the square root. Okay, so you can write this as 100 into square root of 3 into 3 into 61. So we can take 3. Okay, so 3, and here already is 100 is there. So you will be getting here 100 into 3. 3 get outside from the square root, comes out from the square root, and 61. So 100 into 3, 300, root 61 meter. This is the distance between these two aeroplanes after 1.5 hours. This is the 11th question. So simple calculation. So, okay, so just to do it the prime factorization properly so that you can easily reach into the required answer. Now the 12th question. Here two poles of height 6 meter and 11 meter stand on a plain ground. If the distance between the feet of these poles is 12 meter, okay, Find the distance between their tops. So we have a ground, let it be AB, okay, and two poles, let it be 6 meter pole, and this is the 11 meter pole. Okay, and the distance between the feet of this pole is given as 12 meter. What is asked? Find the distance between their tops. Here this is the top of the first pole and second pole. If you join this, you will get to the, the distance between the tops of the two poles. It's very simple question. Okay, so in order to get this distance, this is the required distance asked. Okay, let it be A, B, C, D. Okay, so in order to get this answer, children, draw a line, okay, DE parallel to AB. Parallel to AB. This is a construction, let it be DE. Okay, then see children, here this is parallel by construction and this is the transversal, and we know that this pole and the ground make 90 degree vertically. Okay, they are standing vertical, so 90 degree. So this angle also will be 90 degree by corresponding angles are equal. Okay, that is angle ABC. Angle ABC equal to angle DEC, okay, equal to 90 degree by construction. Okay, that means since the D is parallel to AB, corresponding angles are equal. Okay, see children, see this DC is now comes one side of the right triangle DEC. We can call this as a right triangle. Okay, and since this is parallel, okay, so this will make a parallelogram or rectangle here precisely. Okay, so children, this will be 12 centimeter. This also to parallel to this AB side. Okay, so this side is whole side BC is the length of the height of the pole is 11. Okay, so this being it is 6 meter, so BE also 6 meter. So the remaining will be 5 meters. So we have now CE equal to, from the figure, CE equal to BC minus BE, the whole length BC minus BE. So BC is 11 minus BE is 6. Okay, so you will get 5 centimeter is CE. Understood? Okay, and DE is equal to AB, that is equal to 12 meter. Then how can we get the CD? By applying Pythagoras theorem. Okay, so in right triangle DEC, by Pythagoras theorem, okay, CD square equal to DE square plus CE square. We can substitute. Okay, that is the hypotenuse square is needed. Okay, that is 5 square and 12 square plus 5 square. That is 144 square is 12 plus 25 is square of 5. 169, this is CD square, and we know that in order to get CD, take the square root of 169 and that is 13 meter. So this is the distance, okay, between the tops of these two poles of height 6 meter and 11 meter. That is clear. Now the 13th question. D and E are points on the sides AC and BC of a right triangle ABC, right angle at C. We have to prove that A square plus BD square equal to AB square plus DE square. Okay, we have given only a right triangle ABC, right angle at C. That means you can mark here as angle C as 90 degree, right angle at C, and D is a point on AC and E is a point on BC, and we have to prove this. Okay, since it is given that is a right triangle, you can apply surely this Pythagoras theorem, but not only upon this triangle ACB, but see children, how can we get this AE square? We should get the answer in terms of AE square. AE square should come and BD square should come AB and DE. That means we have to draw some construction. In order to get AE, you have to join AE. Understood? Okay. And how? What is the next one? BD square. Answer should come in terms of BD square. So you have to join BD. Okay, and AB is already joined, and DE square. This side also get joined. So that is the first step. Join which are the sides? First we joined AE. Okay, AE. Then BD. Then what is the next side? DE. Okay, these are the sides we joined. Okay, AE, BD and ED. AB is already joined. And we can see that here so many right triangles. Which are the right triangles? First of all, ACB. Okay, then DCB. Then DCE. And third one, ACE. These are the 4 right triangles, and we are going to apply that Pythagoras theorem in order to get this answer. Okay, so for that, consider right triangles. Which are the 4 right triangles? That is right triangle ACB. Okay, and second one ACE, this triangle. Then DCE and DCB. DCE, DCB, ACE, ACB. These are the 4 right triangles. Okay, by Pythagoras theorem. Okay, I am going to apply upon ACB. So AC square equal to AB is the square of the AB is the hypotenuse. Okay, so AB square equal to AC square plus BC square. Okay, and second triangle ACE, the ACE, so hypotenuse is AE, so AE square equal to AC square plus CE square in this triangle, and DCE, this is 90 degrees, so DE is the hypotenuse, so DE square equal to DC square plus CE square, and the last triangle DCB, so DB is the hypotenuse, DB square equal to CD square plus CB square. Let it be equation number 1, 2, 3 and finally 4th equation. Okay, so in order to get into that answer, you can just add. How this can be added? Okay, see, if I am adding AE square and BD square, that is these two. Okay, BD is equal to DB, doesn't matter. So I am going to add 2 plus 4 implies AE square plus DB square. I am adding the RHS of these two equations. AC square plus CE square, RHS of the second equation, together with the RHS of the 4th equation, CD square plus CB square. Okay, so here we can't do anything. Here we don't want to do anything in the LHS because we need these two terms, answer in these two terms. So we have to rearrange. We should get to the substitution for here 4 terms in RHS, and that should reduce it into 2 terms, that is AB square and DE square. Okay, see children, what is AB square from equation 1? AB square is AC and BC square. So if you have, see children, here one AC square is there and a BC square, CB is BC. So this first and last term together make AB square. AC square plus BC square is AB square. And this middle term, second and third term, CE square plus CD square, CE square plus CD square is equation, from equation 3 you can write this is equal to DE. Okay, this is from equation which are like first and third equation. which means in the LHS AE square plus DB square is AB square plus DE square. This is the required result. Now the 14th question. Here a perpendicular from a vertex A of a triangle ABC intersects BC at D such that BD equal to 3CD. We have to prove that 2AB square equal to 2AC square plus BC square. Okay, that means we have to prove the answer in terms of the sides. See children, AB, AC and BC are the sides of this triangle. It is not given that it is an equilateral triangle. Okay, it is a triangle and from this A vertex a perpendicular is drawn. That means BD equal to 3 times CD, that is given. Being it is perpendicular, you can mark this as 90 degree. Okay, if we have the perpendicular, this triangle ABC, big triangle is divided into now 2 right triangles. Okay, and if you apply this Pythagoras theorem upon these 2 triangles, you can express this in terms of AC square, you will get an expression, and as well as in terms of AB square, we are getting another expression. Okay, so that is the first step we are going to apply. Okay, so since AD perpendicular to BC given, okay, we can consider 2 right triangles ADC and another one right triangle ADB, this triangle and this one. Okay, so we can apply Pythagoras theorem. Here the side opposite to this 90 degree AB square is the hypotenuse. Okay, so by Pythagoras theorem, okay, AB square equal to square of the hypotenuse. Okay, AD square plus DB square. AD square plus DB square. Let it be equation number 1. The same property we are applying for the second right triangle ADC. So this here the hypotenuse is the side opposite to 90 degree AC square. So AC square equal to AD square plus CD square. This can be equation number 2. See children, after getting these two, see here AB square, AC square we need. Here AB and AC. Okay. See in the RHS part of these two equations we have AD, DB and CD are there. We don't want this in our required proof. So for that, in order to you can easily eliminate or you can easily cancel one of the term from these two. What is that? See children, AD square and AD square. How this term get eliminated? We don't want that one. Okay, that means if you subtract this equation 2 minus 1 minus, if you subtract 2 from 1 or 1 minus 2, okay, what will get? See children, 1 minus 2 implies, how 2 equations are subtracting? Just subtract the LHS and RHS separately. That means AB square minus AC square equal to this minus this AD square plus DB square minus AD. You can change the sign and add. So this get cancelled. AD square get cancelled. So in RHS DB square and minus we are subtracting. Okay, CD square. Okay, so now we have this expression AB square minus AC square DB in terms of DB and CD, but this also get a substitution and then only you will get the required result. We don't want these terms. The answer should not come in these two terms. So we have to replace. Okay, we have to replace this in terms of BC. AC and AB are here. So in terms of BC, for that we can concentrate upon this side BC. Okay, see children, what all things are given. Here you can easily substitute here 9 here DB equal to given as 3 CD, no? Okay, so you can easily substitute here C 3 CD because DB is given as BD is given as 3 CD. So here become 9 CD square in the next step. 3CD whole square. Okay, minus, okay, this CD square. Okay, so see, if you square, you will get 9CD square minus CD square. Okay, so both are like CD square, so 8CD square. So here these two terms now reduced into one single term, that is 9CD square, but we don't want CD. So how this CD get eliminated with substituted with BC? We need actually BC in place of CD. We should get answer in terms of BC. See children, from the figure, what is this CD? See children, CD is BC minus BD, the same idea which we used in the previous question. The okay, that means we can apply that result. Okay, 15th level. So we can substitute here. So next we need the substitution for CD. Okay, because CD is not needed. Okay, so from this figure children, CD, what is CD in terms of BC? That is CD equal to, okay, in terms of CD you can write, or in terms of now we have in RHS 8 CD square, but we should get answer in terms of BC because AB and AC are here. So how the CD can be substituted in terms of BC? So look into this side BC. Okay, so can you write this BC as a sum of CD plus BD? CD plus BD, CD plus BD is the whole side BC. Okay, and we know that the CD plus BD is given as 3CD, right? Okay, so 3CD. So from this you will get 4CD. Okay, CD plus 3CD equal to CD plus 3CD equal to 4CD. Okay, BC. Okay, and what we need substitution for CD. So if you keep the CD alone, you can take this 4 to denominator and LHS. That means BC by 4 equal to CD. Now we got the substitution for CD in terms of BC. That is what we need. Okay, so I am going to substitute here 8 into CD is BC by 4 whole square. CD square, don't forget to square the CD. So, okay, BC by whole square. So in the next step you can write 8 BC square divided by 4 square is 16, and this 8 in 16 2 times. So you will have BC square by 2 in the RHS, that side. That means we have now AB square minus AC square equal to BC square by 2. Okay. So in order to get into our required result, we are just taking this 2 to LHS cross multiplication. Okay, which means 2 into AB square minus AC square equal to BC square RHS. Okay, so 2 is taken to LHS under multiplication. In the next step we can apply this distributive property. So 2AB square minus 2AC square equal to BC square. And what we need 2AB square alone. So I am taking this minus 2AC square to RHS. So 2AB square equal to BC square minus become plus 2AC square. Okay, this is our required result.